Workbench and how to put in command blocks and how to use them. I just want to preface this by explaining to those that maybe aren't familiar with command blocks what they are and kind of when using command blocks. So to start off, you're probably familiar with Workbench, at least Workbench environment. This is you can your model and solve and everything in this interface. However, when you hit the solve button in Mechanical, you're actually writing an input file. You're opening up ANSYS Classic in the background in batch, and that input file gets submitted to ANSYS Classic. Then ANSYS Classic analysis, and then when it's finished, the results come back into Workbench. So, this is a seamless process where when you're in the Workbench environment, you might not even know that this was happening, but this is, understand really what we're going to be talking about today, and that we're dealing with this input file that gets created from Mechanical. So it's in a Mechanical environment that you see has to get written out to a corresponding ANSYS Classic command, which is your full model that shows up in Classic where it's solved. So this is really what we're going to be talking about today. How do we interact with this input file? How do we stuff our own commands into this to control different things? So if you input file, that's very easy. You can just go into Mechanical, highlight Solution, and Tools, Write Input File, and that will route that text. It's just an ASCII file. You can open it up and see that everything there is everything that was in Mechanical session. In terms of the finite element information, though, loads, boundary conditions, mesh, the geometry will not be in there, though. So just keep that. But that is the entire input file for your model. And just as easily open up Classic ANSYS, choose File, Read Input From, and read that input file in, and then you'll have your entire model that was Workbench in Classic ANSYS and see everything that's in there. So, since we're going to be some things in Classic ANSYS with command blocks, why don't we just build a model in Classic ANSYS from the start and then stay in here and not have to worry about Workbench? It's certainly an option to you, but if you Workbench, there's a lot of features that help speed things, and things are automated for you, and that it's very nicely with your CAD systems. You get parameters, you get bidirectional associativity, and that's when any changes you make in your CAD end, those can flow through all the way down. A lot of times you just have to hit refresh, and the whole analysis reruns, your boundary conditions, loads, and everything stay on the model. So that's something that's very nice and easy to have. There's better or nicer, more meshing methods, and then some automatic contact detection between the bodies. All these things really speed up the analysis time that aren't available in Classic ANSYS. So be the reason to use Workbench, but just something specific that you want to tweak with the command block, like maybe different element types, put in some material properties, change some settings here and there in the analysis that might not be available in the Workbench GUI. So that's where command blocks come in. You just make those changes that you would like. And you have some scripts that you're used to using all the time, doing some post-processing, some different things. You can still use those scripts. You can stuff them into a command block. So that's high level what we're talking about here. And the last slide I have for Workbench is the outline tree is structured from model to the analysis environment is in pre-processing in Classic ANSYS. Under the analysis environment is our solution, and then solution here is in post-processing. So the input file is essentially structured this way. We can set up different command blocks in these locations to access different information. So that's a quick action. So I will go over here. Model or up in Workbench. We saw that's a half symmetry model of a pillow block. Just some unload on one, and just fix the bottom down here on the other side. And I have some deflections and stress. I'll just use as a simple model to demonstrate some command blocks. So what if we wanted to do our analysis on this? So I can go into the project page and then just drop another structural in here, and then we can do the same load and same results in here. So, I get up, and then maybe in this case, I put on some different boundary conditions and loads and solve this other analysis. Sometimes it's nice to set it up this way because then you can maybe chart or compare the different results between these two analysis blocks. But one thing we're not able to do with this type of setup is if we have any connections or maybe want to change the material properties on a body, everything that is in this tree above this first environment gets shared between these two. So with this type of setup, there's no way to change the material properties for this one analysis block and not affect this one. But it's very easy to do with a command block. We can do something like that. We could set this up in Workbench and be able to do this, but just to illustrate this. So on the body, if I insert a command, then you'll see there's some text that shows up in here. That commands inserted in this file will be executed just after a material definition of Prep 7, that's preprocessor, and the material number for this body is equal to parameter mat ID. So on this body, this is going to classic ANSYS, it's going to material assigned to it, and the material number is going to equal ID as the parameter. So I'm just going to save that number, whatever it is, maybe it's 1 or 5, as my own parameter. And I will go down into the next analysis branch down here too, and insert a command block in this location. And commands inserted into this file will be executed just prior to the solve command. So we're in solution, and on solution command, which this works, change the material properties. So this defines the material property modulus of 10 to the 6. And using that parameter again, this is a number that is equal to the material that's assigned to this body right here. So what I'm doing in this case is I'm overwriting the existing material that's on the body. So go and solve both of these, and we'll just take a look at what's happening here. Let me add, and then we'll also, while this is running, we'll take a quick poll. So there's a poll window that will pop up on your screen. And so if you can answer this question, are you currently able to add command blocks on your own? I just want to get a feel for who might be using it, or if you're familiar at all with them. So you can submit your answer. Looks like most everyone is submitted, still working, so let's give you a little bit more time here. All right, that's probably not it for those that are going to respond. So I will close the poll, and I'll share that with you. So it looks like 40% have, so that's great. And I think it's another roughly 40% haven't or could with some help. So that could be either from difficulties not knowing classic ANSYS or just didn't know the features there. But if either of those are the case, you can certainly call. I'll help you get going if there's something that you do and maybe just need a little help to get going there. So this model's finished. If I go back and look at what happened here, this was the original analysis. There's a stress on this fill block portion, like 1350 psi, and then look at the stress on this next part, and it's about 1,000. So we can see that that did change the material, change the stress. So that block did work. But one thing that I want to bring up with that command I inserted is that I hard-coded in a number. 10 to the 6 was assuming English units. Inserted the command block. Those were the units that spit out right here that the unit system was pounds. So if I went in at this point and used units, changed it to metric, then this command block's going to be not going to be valid. So you have to be careful of that. And another example of the two is also in post-processing. If I insert, say, this energy for the body or thing in the model, this shows up as 1 to the -6 BTUs. So I could get this information through a command block, and this is the first post-processing command block we've seen where files here are executed just after post 1. We're in the general post-processor class ANSYS. So the first thing that we need to do when we're in there is read in a set of results that we're interested in. So that I just element table all the elements for strain energy. I sum up that element table, and then I get the sum from that, and I store that as a parameter here. I'm just going to evaluate the way I talk. So at this parameter name, specifically with MY underscore as the prefix, because if you notice in the details of the command block, there's search output and underscore. So long as we set up whatever the prefix is in here and make our parameters match, then it'll show up in the results down here. So you can see them, those show up in here. And you could check this box and make a parameter out of that. I'll come back at the end of the webinar. So what you'll notice here is that if we just untable the results and then spit that back in here, this is e to the minus 2 as opposed to 1 e to the minus 6 type of magnitude. So that what's on here, and it's just that these goes up as BTU units, and then the units here are the consistent England's pound units. So we just need one more parameter. Just divide that value I got by 938, and then you can see that value matches up down there. So you just have to be aware of the units. So this has always been one of the concerns with Workbench has been the lack of consistent units in classes. So Workbench converts all the bin thermal units, or basically the BTU quantity, into equivalent pound units when it goes into classic ANSYS. So when you have the database and you export or run it, it's going into classic ANSYS. All material properties, loads, anything that needs to get converted to consistent units does. That also means that in post-processing classes, those are still in those consistent units. Workbench converts them back. So really the key here is just remember that base. So it's enough to convert it, just as you're aware of that. So that's one example. Let's maybe get a little more sophisticated with the problem now. What if we wanted to take this body right down here that is structural steel and come to a composite, essentially, with a layered shell in those. Since this is a solid body, that's something that's not available currently in the GUI. You do see this button right here is layered section is grayed out. If I did have a surface body in here, that is a feature that's available in this GUI. But layered sections on solid bodies is something that's available in classic ANSYS, so we can access that functionality and work through the command blocks. So the way to set that up in here, we just take that that we have on this body. So just some elements, and use the thin sweep method. Drop the mid-side nodes and use the solid option. So the elements that are in this body are going to be the solid 185 elements, and that automatic thin just orients the elements such that the through thickness direction on this plate is aligned with the thickness of the elements. They're just all oriented the same way for this to work. So the solid body, I'll insert a command block, and then the parameter mat ID is equal to the material number. That's true. What's also true is that on this body, the element type, real constant, section number can also be the same. So what we can do is we can access the element type for that body through mat ID as well. And I'm going to change the key options for those solid 185s. I'm just going to make it a layered solid, and then I'm going to store all the information for all the layers with these two changes. That's easy enough to change some of the options on the element type. I haven't done anything in terms of assign the sections to those elements. So we can do that by inserting another command block. Do this in the analysis environment. Put in a command. And then in this command block, right before the solve, so we're in solution, but this is one big long input file that gets created and then submitted to ANSYS solution afterwards. That's perfectly fine. So that's what we're doing here. So the first thing I'm doing is I'm selecting some elements. Now, this is the key of how I'm tying this command block into the geometry that I'm working with, or really the elements I'm working with. So I create a name selection on the body right here called sandwich for that little sandwich piece on the body. To do that, then this is an element component that created and sent over to classic ANSYS. So I can use these name selections as components and select. If it was a surface, edge, or point, then it would be a name selection would go over as a nodal component in classic ANSYS. So on this command block, I am selecting those elements, base name right there. So I select them, and then I get the material section and type numbers in here. Pretty, does thing a little bit different than that first example of using that parameter, but this does the same thing. Get that information, then I overwrite the existing material properties that are in there and put in some properties, and then also the section properties for the layout in there. So those are the commands for doing that, and then go back to solution, and then this outres command. Something I generally put in if I'm doing something specific with the command blocks. The reason for this is that this write out all the results possible, results file. In Workbench, finance analysis settings, output controls, you'll see that these outputs for nodal forces, contact things, Workbench turns off a lot of the output to help reduce the file size. But I want to make sure that since I'm putting in other elements, these are going to have their own unique results. I want to make sure that those results are written to the results file. So generally, I'll always put that in, that I have the results in there. So I can solve this now, and then we can see the effect of putting in that command block on the stress. So the stress used to be 1350, now it's 14. So we see a difference in the results. We can see the flex and everything, but this kind of the thing in mind is that Workbench knows what it creates. Right? So I created some layered elements down here, but they don't show up that way. It doesn't know that they exist. Results are due to those being in there because the classic ANSYS know that those are layered elements, but we don't know that in this GUI. So insert a command block in here, and then we can do something with post-processing to see those. So this block is off by resuming the database under the analysis settings to save the ANSYS Classic database. I only did that so then I could read the components I get defined, which is that name selection. Those don't get stored on the results file. Otherwise, just read in the set of results. That's why it's in there. So I select just this body down here, and then I'm going to create a plot of that. So let me evaluate this. So these are just some view settings, and then this is /show PG. We'll take a picture. And it's a picture of the stress in the x direction for just those elements that I selected. You'll notice if you put in /show PNG, it'll put in a picture below the command block. And the picture that we see in classic ANSYS, if you were to write a file, read the results in, and look at it in that GUI. So that picture shows up in here. And we see that those are you have 10 layers through them. I turned out the edges so that we could see that. And then you see the stress distribution in those elements. So it did make that change. We can see those results in that way. So that's one example. There's some more things that we can do with this. But let me just get another quick poll. Just give me a second to open it up here. So the next poll that we can take, so we had a situation where a command block helped. You know a little bit about them. Do you think that there's a case where maybe it was in the GUI that done it with a command block? And if you have created a command block, there's not a way to the poll to submit the your answer to that. If you have created one, mind submitting through the chat window what the instance was where you needed a command block. Certainly when sharing some, or if anyone wants to submit that. So I'll just give you time here to finish with the poll. And looks like let's go. It's a poll here in a few seconds. And used to tie some coincident nodes together. There's certainly going to be misses for our command blocks that would have them to merge them nodes together. All right, let me share the results with you. Anyone else wanted their uses for their command blocks that you've created? Please go ahead. So it looks like, yeah, maybe did know that command blocks exist, but maybe just didn't use them. And again, if that's because you just made the commands or how to use commands from classic answers, like I said, we can always help you out a little bit if you need to kind of get on that. So we could always point you in the right direction if you give us a call. All right, so let me go back and show you a couple more things with the command blocks that we can do. Next thing do is this command here where I define the section properties. Right, so these are the answers commands for putting in a bunch of different layers, and they're that amount thick, and then there's a whole bunch of layers. So what if we change the geometry? We wanted these thicknesses to update when we did that. So go into Zilla here and just look at how this part was created. I just sliced this pillow block by offsetting this plane 0.2, and I made a parameter out of that, and then I sliced it so that 0.2 parameter corresponds to the thickness of that body right there. So that's a geometric parameter I already have set up. Add that into this command block that I have here. So the way that I can do that is just select arg1. That's going to turn this into an input parameter. Input parameter into this command block. So what I'm going to do is it's going to get assigned a value from Workbench. And then it has the total thickness, and then a total thickness divided by 4 to get the layers, because I have 4 layers in here. So you could do this many other ways, or maybe you want to change the logic, but this will just show you that 4 layers get created based on the thickness of the geometry parameter. Now, I have sets, but I need to link those two together. The way that I do that is a quick page, highlight the parameter set to go in here, and we see we have that geometry parameter of 0.2. We have this parameter from that command block that shows up as arg1. So if I take this parameter and go into the properties of that, I can set an expression where I put in P4, the value of that geometry parameter, and now this is a derived expression where those two are now linked up in here. So I'll refresh to send that parameter back into mechanical. And now I highlight that command block, and I see that a value associated with this parameter arg1. So now this is going to be 0.2, which gets put in here, and so on. So if I resolve the model, then it should take that value, and then I can look at the picture and then see that it did update everything. So just about done. There we go. So now we can see that the picture. There are 4 layers through those elements, and looking at the stress because of that. So they're parametrically tied together. Like I said, in the output parameter I had here, and there could also be parameters as well if you wanted to do something with those. So being some parameters that can be useful. There's one more thing that show you, I think, that we can fit in the time. If I made this a multi-load step analysis, right? So I set this to 2 load steps. Now on this command block, this shows up where you can set the step in which you want that command block to be applied. And now this is the first step. So the second command block in here, I want all the commands that are inserted in this command block to be executed on a certain load step. Maybe I'll say load step 2 in this case. Step 2, what I'm going to do, maybe I just grab those composite elements and kill them, or remove the stiffness from the simulation and the second step. So this is that. So we run the first analysis with this command block, get the results, and then the second step, maybe the properties have degraded, or whatever you're doing, you want that for some reason. We do that on the second step. I will know that on this command block, it gets executed as a sense solve in a multi-load step analysis. Be careful what you put in here. You wouldn't want to put in, go back to preprocessor and then go back into solution, because then that's going to, basically analysis over where you overwrite the results that used to be there previously. You need to see in the solution processor if you're going to put in commands on a certain step, just the way it needs to be. So that's it for the time I have. So let me just check here. Interested in any other e-learning webinars, please check us out online, and the ones that we have coming up. Let me just see if I have any question here. Okay, just about parametric variables. We went to make surface effect 154 elements to add a pressure. Certainly can. You can create a name selection on a surface, something like that, over as a nodal component. At your command block, you'd want to grab the nodes, and then you could, depending on how you do it, you could set up element type with surface 154, and then you got those nodes, and then do an esurf on that. Something that you can also do for two analysis if you wanted to put action in the out-of-plane direction, which isn't something available in the CAE. So you can certainly do things like that too. Any other questions? Related to the APDL language, if you want to figure out how to use these different commands, what's needed, I'll go to the presentation here quickly. That the best way is to just do what we have here, where you write out that input file and then open up classic answers and work your way through the GUI by manually doing what you would like in here. And if you choose, there's under this menu, list files, log file, you can see the exact commands for what you did in the GUI. And also all the commands are available in the help too. So that's, I'll just say really quickly, probably the easiest way to get started. But if you question, want to get going, just give us a call. All right, well, I think that's it. Anyone else that submits a question, I'll just reply to you by email. And thank you for attending. And please join us in any of our other upcoming webinars.